All right. Do you hear me? Is it on? Can you hear me? Yes. I was thinking, no, you couldn't. Designing the integrated curriculum. We have chosen a strategy in the CDIO model, which is weaving skills, competencies through the disciplinary courses. The reason is, of course, that we had an existing structure of a program with existing programs made up of basically disciplinary courses. So this is a strategy that can be explained from the starting point of the founding universities. Some of you may come from universities where the starting point is different, and also all kinds of contextual variables will affect what strategies you want to use. So I think it's important to stress that whatever you find, we offer our experiences as something for you to pick from. Whenever you find useful ideas, use it, but don't see this as prescriptive or normative. We are not preaching, it's not a religion, it's not a club. It is, we just offer our experiences for your consideration. Because I think in order to influence change, in order to have an effect at your institutions, you really need to own this locally. You need to translate it into your own baby, if you wish, and not just take a cookie cutter and press it onto your context. Here is basically the idea of the integrated curriculum. If you take an existing, old, boring engineering program and you want to make a good engineering program out of it, we have used the strategy of weaving skills development through the courses. So it's what we would call the subject courses that get the responsibility to help students develop skills and competencies. That is not an obvious thing to do for a discipline-led course. So I really need you to understand the rationale behind this, because when you come home and you explain to a colleague, this is what we should do, he or she, if they don't understand the rationale for this, they're not going to be of much help to you. So we're going to do this thoroughly. You can see a few things here. One very important idea is that you have an explicit responsibility for courses to contribute to program objectives. I think it's important to be explicit, because the situation where all courses are supposed to address all skills is very similar to the situation where no course contributes to any skills. So explicitly assigning responsibilities is key here. Further, you can see that in this, it's just a symbolic representation, but you can see that we haven't assigned responsibilities to all courses. Some of them might be left to their own devices. One of the reasons is that it's much easier to work with faculty who are willing and able. And sometimes you have human factors in your program, which it's much better to focus your resources where they will have an effect, rather than trying to push people who are unwilling or unable. So that's one of the reasons why some courses might not get or ask for responsibilities. There are two standards, if you want to look them up in your handout. Standard 3 is the integrated curriculum. And it contains really two ideas: that the disciplinary courses should be explicitly connected. We should work on the connection between courses, and also that they should integrate the personal, interpersonal, I can't say this, so I say engineering skills. I think it's a shorter thing to say. I've tried for 10 years to learn to say personal, interpersonal, and product, process, and system buildings. Never mind. Whatever, as my son would say. Standard 7 is basically the same thing, but it is on a course level. So that once the course is assigned responsibility to have furthering a skill as part of its learning outcomes, it will design integrated learning experiences. So these two standards are basically the two sides of the same coin, the integrated curriculum idea. Okay, so now, why this integrated approach? Because it is a difficult strategy. We have been doing it for 10 years. It is difficult. Why do we want to do it? The reason is that we see these skills, the engineering skills, as context dependent. And therefore, students have to learn them and we have to assess them in the technical context. I'll show you what I mean. One faculty member at my university had as a course goal in one course, students should be able to communicate engineering. And I say, what does that mean? What does communicate engineering mean in your course? And he just told me this, and I wrote so the paper almost caught fire. He said, it's when the students can use the technical concepts comfortably. It doesn't hurt their mouth to pronounce it. It means something to them. They can argue. And my favorite is this one. Students should be able to develop ideas through discussion and collaborative sketching. What does that mean? And he said, it's when they get a problem and they gravitate towards a whiteboard and they start sketching and they start discussing and they forget everything around them and they get very involved in this discussion and they erase and change and then they start quarreling, really quarreling. And they use technical arguments and one of them says, this is not going to work because, and you see they're applying the knowledge. And then they have to do a little MATLAB thing and one of the students says, ha, I told you so, and they have to change it. And Stefan is his name. He's standing behind a pillar and he's just enjoying the scene. He's smelling like there was bread in the oven. It's starting to smell like engineers. Students are turning into engineers. And in fact, when you see this list, you realize that these competencies that are listed in the CDIO syllabus, they are engineering skills, and we have to see them as engineering skills. At my university, if anyone says soft skills, I will hit them hard on the head with a book, because these are not soft skills. When you see them like this, you realize they are legitimate learning outcomes for an engineering degree. They are not anything that is separate from technical knowledge. In fact, they have everything to do with technical knowledge. They are, in a way, they are the channels through which you can express and apply your technical knowledge. And not just communication, that also goes for teamwork and ethics, etc. They are all ways to express your technical knowledge. When you see students performing these kinds of things, it's impossible to say where the communication skill ends and the technical knowledge starts, because they are one and the same. It's more the answer to the question, in what way can you use your technical knowledge? So these are as much an indication of students' understanding, students' working understanding of the technical fundamentals, as it is the result of practicing communication, practicing teamwork, practicing, etc. One other thing you see when you see this list, and this is a sensitive topic, when you see this list, you realize you can't send your students away to the language department to do the communications course, because they need to practice communication skills in the technical context. That means you have to teach it. The engineering faculty have to teach it. Engineering faculty also have to show that these are legitimate learning outcomes in the engineering degree. They have to vouch for the importance, and they have to be role models. So we call it embedded skills, and we see them as completely inseparable from technical knowledge. And I haven't made a list like this, but you could do it for teamwork, you could do it for ethics, etc. All the things in the syllabus, they have they are ruling with technical knowledge. So it's not about adding soft skills to the students. It's about educating engineers, actually. When they have those engineering skills, they are engineers. If you look at the list, you might be, or this discussion and collaborative sketching, that's a learning outcome for communication skills in Stefan's subject, which is lightweight design. In other subjects, in other parts of engineering, the learning outcomes will be different. So I think it's important not to just say, oh, students in all programs have to learn communication, then this is communication. It will be different in the different technical contexts and different for each subject, etc. So collaborative sketching will be complete nonsense in many other courses. So you will have to do the translation. What does communication skill mean, or what do all these engineering skills mean for your context? So some of the things we had to, I don't say soft skills, because they are not soft, and because they are not something external to technical knowledge, but they are at the core. It's not about adding more content. I had a professor at my university said, but I know nothing about communication. How can I lecture communication skills? No, you don't lecture skills. Skills are developed when students get to practice themselves, when they get feedback, when they can reflect on experience. It has a completely different nature than theory. So you're not supposed to lecture these skills to students, but it's rather in the format that they learn the technical knowledge that they also learn the skills. So it's more about changing the format of the courses rather than adding any more content. Wasting credits. Some lecturers at my university said, are we going to waste credits on soft skills? What is this? And I think it's obvious when we have this integrated view on the skills that we realize that by practicing skills, students will at the same time reinforce their technical understanding, and they will turn this theory into working knowledge. They will improve their understanding by expressing and applying the knowledge. They will start to own it. And it cannot be taught separately, I think. Or maybe you can have separate things as well, but I think the important thing is to integrate it into all courses, or most courses in the curriculum. Here is the second piece in the puzzle. We have this program planning stage when we assign responsibilities to courses. And we do it in the format of intended learning outcomes. So a course will have a contribution to the program learning outcomes. A part of the program learning outcomes are taken care of in my course. And then we need a model for course development. And this should be familiar to some of you because it's really the standard in this field now. We start by formulating the intended learning outcomes. What is it that the students should be able to do as a result of the course? And then consequently, we design the learning activities. And this is such a good question. What work is it that the students should do in order to reach the learning outcomes? That's different than the design question, what am I going to say in lectures? What work is it that the students are going to do to reach the learning outcomes? And then assessment is aligned to the learning outcomes. What should the students do to demonstrate that they reached those outcomes that we intended them to have? So in this course, among the desired objectives, this course has a contribution to the program objectives. It has a contribution to the engineering skills of the students. And that means it has to affect the learning activities, it has to affect assessment. That's what we mean by integrated learning experiences. One example, and you will see more of this at 2 o'clock this afternoon, is the design implement experience. This is where we can really help students develop engineering skills. And at 2 o'clock, Jacob Kuttenkeuler and I will describe and analyze design implement experiences from a learning perspective. So you will see lots of beautiful pictures, but you will also see that this course, this type of course, is designed to meet these kinds of learning outcomes. The complex engineering skills that many faculty think are the hardest things to teach and the hardest things to assess, but we're going to show today at 2 o'clock that it's absolutely possible to assess these skills and to develop them in students. Johan, please. Oops.
Right, so there was, which is the...
Ska jag stänga av den bara?
Which one you want to use? Which one you prefer? I can use that, so it's not so sensitive. Sit in the middle when you turn your head. There? Yeah. Is this all right? Yes. Thank you. Okay, so Kristina has gone through the sort of motivation for an integrated curriculum, and I will discuss a bit on how to work with them so that one can come up with one. And the starting point for this kind of process or any kind of starting curriculum design process could be some national baseline for what an engineering education is. And national regulations are known as ABET or CAB, etc. in Canada and so forth. And they are a baseline for what you would do if you're designing an engineering education, a sort of minimal standard or a threshold. So, but the real task in going for a CDIO program or any other program is really to make those baselines into your own and specialize what is important for your faculty, what is important for your stakeholders, what is important for your students. Specialize, make a profile, be more specific about what you want. Because that is the fundament for designing a strong program, not being sloppy in this, but trying to really understand. And we did quite a lot of work on this topic in the early phases of the CDIO project, where there was this support from the Wallenberg Foundation. And we went out and surveyed alumni, industry leaders, and so forth, and asked them, how do you rate these different skills that one could imagine and that are listed in the CDIO syllabus, going from engineering reasoning to experimentation to systems thinking, and so forth. Finding out what is important and finding out what is missing. And what we learned then is perhaps some things that did not surprise us, that engineering reasoning is fundamental, but perhaps that after those, and almost as important as perceived by alumni, were teamwork, communication, and design. And that was perhaps not as strongly reflected in our programs at the current state. So that reminded us that, well, we need to really design our programs to develop those skills. So, and then you can find that there's a lot of skills possible, but some kind of priority helps you get along. And another startup work would be to benchmark the existing curriculum for inclusion of CDIO learning outcomes and topics. And someone related to, well, we understood CDIO right away because we felt that that was something that we were doing all along. And to some extent, that is probably also true, that there are many good examples in a curriculum that are also related to CDIO topics. It could be project work, or it can be something that has to do with active learning, or it has something to do with communication and so forth. And those are a natural building point, starting from, not saying that now we're going to do everything new, but build on your existing strengths. But also try to understand what is missing, right? Are we teaching communication in a way that builds on other strengths, that reaches our goals? And by the way, what is our goal? So If we look at the national requirements for engineering education, you say that should be able to communicate in an international context. Okay, and then we could ask our industry people, what does that mean? And for the last decade or so, they might have said, well, we have our American owners in our companies, and we need to be able to communicate with Americans. So, and okay, that might mean that we should be good at speaking English, fine, perhaps understand an American culture, work with Americans. On the other hand, if we ask them now, they will say, well, everything is happening in China at the moment. So what would that mean for communication skills in terms of language, in terms of cultural awareness, and so forth? Is there something missing in our programs now that we did not prepare for before? Other kinds of benchmarks, going on study visits, looking at other programs, and so forth. Finding out ideas to talk from. There are many ways you can do this in. Interviews, focus groups, questionnaires, comparative studies, look at best practice programs, publish data, and so forth. And if you have that, you might wind up with something that you can call a baseline curriculum. Okay, so you have a program, it belongs to a particular discipline. Maybe there is something that is a rather logical or expected starting point for curriculum design, which looks a bit like what you had before. A number of courses spread out through the years in some kind of sequence. Okay, and we could call that a baseline curriculum or a non-integrated curriculum. But the work that goes on after that to turn this into an integrated curriculum would include a few more things. One is to think about, well, is this the right course structure? Okay, if we have an integrated curriculum, maybe we should look at the collaboration between different courses. Maybe we should merge courses, split courses, or should we retask existing courses? Well, you have a project-based project course. It teaches how to design. Maybe this course could also teach how to communicate, plan projects, or so forth. Or you might have a course in materials. Maybe that course can also be used to teach sustainability of some kind, and so forth. So you reconsider what each course does, but not necessarily sort of throwing out courses and picking in new ones all the time. But at some point you might also want to consider that, well, we really need a new course in design and innovation or sustainability and so forth. But that's only one aspect or one opportunity. And in this work you can think in very many different ways. How can you build together your curriculum? Well, maybe you think about sequences, maybe you think about blocks, maybe you think about buses or backbone structures where several courses during a semester are tied together with some common element. Link and merge, for example, two courses that provide disciplinary knowledge first and then combined in a project towards the end, say a design and manufacturing project, or some things that go on simultaneously. For example, a mathematics course and a solid mechanics course might collaborate over MATLAB applications of solving partial differential equations or simulation. So there's an entire toolbox of ways of connecting a sort of baseline curriculum into an integrated curriculum. And only the imagination is so far. And one particular one that we have tried over the years is something where you ask the teachers of the program to think about their courses as black boxes, and to the other teachers in the program say, well, this is the previous knowledge and skills that I know, that I need to teach my course, and this is what I think that I deliver to the rest of you people. So, and I think it's quite common to find that people have a pretty good understanding of what students need to know when they come to their course. You need to be able to use Laplace transforms in order to come to teach, to learn in control theory. But on the other hand, have a very vague understanding of what goes on after their course. How are students actually using control theory in other courses, in mechatronics or machine elements and so forth? So But by forcing everyone to do this, being in the same rule, comparing notes, you have a totally different fundament for tying together the knots in the curriculum, both in a disciplinary way, but also in a professional skills manner. So if you are doing this, and again, you might want to prioritize some, at least to start with, some key learning sequences. And what could that be? Well, it might be communication, it might be teamwork, it might be sustainability, it might be design. Okay, so you have identified those, and then let's see what it might look like. And then we come back to the chart that Christina showed early on, and this is what an integrated curriculum can look like. Because here we have pointed out 4 different tracks or worms or planned learning sequences, some other word for this. We have retasked courses in order to take some responsibility. Course A is now also responsible for written communication and for oral communication. You can imagine that you're writing a report and then presenting it to the class. On the other hand, Course B, which takes place at the same time, is responsible for teamwork and project planning. Okay, so all of the courses are doing something sort of beyond their disciplinary content, but not everyone is doing everything. Okay, it's a shared responsibility between the courses, but shared responsibility for the teachers. That we all understand that we are all responsible for all of this beyond our disciplinary knowledge, but we don't everyone doesn't have to teach teamwork, communication, sustainability, design in all of their courses at the same time. A misconception that you can find somewhere. And the second thing to see here is that these kinds of learning events build on each other. So if we have oral communication first in a course in year 1, we have it in year 2, year 4, and so forth. But the point is there that it should not be the same, right? When we have looked at how we teach presentation skills, for example, we've seen a pattern where someone comes in year 1 and does an excellent talk on how to make a presentation, and then the students might do one, and then in the second year, another person comes in and does an equally excellent talk on how to make a presentation, and then the third. But it's the same talk, essentially. There's no idea of how to progress. So maybe we should teach one aspect of oral communication in the first year, another one in the second year that builds on, and then a third one in the third year that builds on, etc., in order to get the most out of our curriculum. And I think that sometimes we see that we're a bit sloppy with that. So, and the risk is even stronger if teachers are exchanged and someone new comes in and has to take responsibility for this or that. So this is the key picture of an integrated curriculum. And then if one has time, one could delve into details, work out this sort of what exactly is going to go on in the different courses. And I'm not going to discuss this, but you can see for the first one that a course called Unified Engineering from MIT has the responsibility for write short individual structured reports, create sketches, charts, and simple graphics, practice simple interpersonal communications. That was the responsibility for that course. Whereas towards the end of curriculum, you have another responsibility, write large collaborative reports of a briefing nature, and so forth. So there is an idea of progression. The responsibility is distributed towards the different courses and projects and so forth. Then another aspect of an integrated curriculum is really to have it integrated in away from goals to conduct. And we're don't have so much time to look into this, but we have developed a concept called integrated program descriptions, where the idea is that to support the entire curriculum design process, from identifying the purpose of a program to elaborating a program idea, program plan, goals, program design matrix, where you map goals to courses, and so forth. But there is more material to read about that. For example, in the description of the vehicle engineering program at KTH, which goes into all of these levels. So here the program description is used to explain the logic of the program and to include all the goals and include all the courses and define the progression between those. So to wrap up this introduction of the CDIO curriculum design process, there is a starting point where you look at the needs, look at the national benchmark, and then create your own needs for your own program. You can get ideas for a new program by benchmarking, using what you have already, finding out the gaps, looking at other programs. You can then use the matrix here with the worm here as a tool when you're developing the integrated program and working out the planned learning sequences. And then you move on to the course development and fine-tuning of the curriculum. This was a quick run-through of this process. I'll just leave you with a few minutes to discuss in pairs this question. To what extent does your program have clearly documented evidence of where students are taught what engineering skills? So please turn to your partners or someone that you don't know was the idea, and we'll discuss a few minutes and someone will comment on it. It's on? Okay. Thank you all. I hear that there was a lot of discussion here. Jörgen, I know you had some input to.
I can say something very short. At my program, electrical engineering, we have discussed it with the teachers' faculty, what is engineering skills, and engineering skills can be a very wide topic. From writing technical reports to more subject-oriented skills. And we are working at improving these because I think it's very important to identify these learning sequences in the program. But it's difficult, that is what I can say.
How about you, Juan? You had some experiences from your program. Yeah.
Yes.
Wait for them.
Well, I'm actually a student of architecture, which is not actually an engineering program, but it's close in many aspects. And for us, I think even if we haven't thought in the terms of the CDIO sort of curriculum, we have made many of those steps, but our problem is not to specify them and to write them down in an excellent curriculum for the education, but rather to make them happen with the resources we have at hand. So that's our problem, and it's of course a communication problem mostly.
Oh, thank you. I think we need to move on to the next session, and but we'll continue the discussion on this topic and others. So, Andrew, please.